Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Rat Run 23, Notable Differences by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains contains the digits 1 through 9 exactly once each. Aim of the experiment. I'm going to be calling them F and P because I don't know how to differentiate them so that they sound different. So F and P must both reach the cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, or pass through any thick maze walls. The paths may not share cells except where they meet at the cupcake cell. Okay. We don't know. I think we'll label this one F and this one P because they are Finks and Finks, and that sounds the same to me in both. If I were to hear it, so F and P. So the paths cannot share cells except for the cupcake cell, and they cannot visit any cell more than once or pass through, and they can't cross themselves too, and they can't pass through any thick maze walls. As well as moving orthogonally, F and P may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So, for example, if F were to go, if F were to do something like this, it cannot cross that way because it would be crossing through a round wall spot, which is not allowed. What are some of these things in the puzzle? We have black courants, where if two digits are joined by a black courant, then one is double the other. So say this was an example, a 2. This would have to be 1 or 4 to make sure that one digit is double the other because there's a black courant between them. We have red courants, where if two digits are joined by a red courant, then one is even and the other is odd. So if we had, say, 3 here, this would have to be 2, 4, 6, or 8, because 3 is odd, so therefore it would have to be next to an even across from it on the red courant. We also have grapes, where if two digits are joined by a grape, then they have a difference of at least 5. So, for example, if this were a 3, this would have to be 8 or 9, because these digits must have a difference of 5, and the only digits which have a difference of 5 from 3 are 8 and 9. And these are the tasty little treats that F and P can pick up along the way of the test. Now, what is the test constraint? In this experiment, F and P both visit the same number of cells. Interesting. For any pair of cells, one on each path, that are the same number of steps away from the cupcake cell along their path, their digits will always have the same difference from each other, which is to be deduced. And this difference equals the digit in the cupcake cell itself. For example, if the third digit visited by Finks is a 5, or F is a 5, so say this was a 5 here, and then the third digit visited by P is a 9, then the cupcake cell would contain a 4. Interesting. So the paths have to have the exact same number of cells in them for both F and P. And for any pair of cells on the path that are the same number of steps away from the cupcake cell, their digits will always have the same difference from each other. And that difference is equal to the cupcake cell itself. So that means this difference would have to have a difference of 4 also, if that were the case. Interesting. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, F and P are going to have to go through this central cell. So, they're going to have to go this way and this way, or come in from this way and this way. So we'll mark this as the red path, we'll mark this as the blue path. So red has to go there, blue has to go here. We don't know which ones of these is red or blue. It can't cross. So if red goes this way, that means blue, this can't cross over. So this has to be red then. So this is red, and this is blue. So these have to be matching that way and that way. So this difference has to be that digit. This difference has to be that digit. And this difference have to be that digit. So this digit is not going in box 2, cannot be here. It must be on the path, which means it must be doubleable, right? Because since it's one of these two, the difference between whichever one corresponds to these must be on the other side. So that means this is doubleable, which means it's 1, 2, 3, or 4. Okay, so we do know then this cell cannot be here. Well, that's not true. That is not true. So it could be here if this is double the value of that. It cannot be true that this doubles there, and then this digit is in one of these, because then the double would have to be there. But we know it's doubleable, so that means 1 double to 2, 2 double to 3, 2 double to 4, 3 double to 6, or 4 double to 8. So this difference has to be 1 through 4. That means this is 1, 2, 4, 6, or 8 to be double of 1, 2, 3, or 4. Or halved of 4 specifically, or 2, right? What are the possible combinations? Okay, so this can't be 1. If this were 1, that problem is that this would be, that's not true. Okay, this could be 1. What are all the possible combinations then? If this is 1, this is 2. Okay, so this can't be 1. If this were 1, this would be 2, to be in a 1 to 2 ratio. This would have to be even, and the difference between them would have to be 1, but even and an even can never have a difference of 1. So that doesn't work, which is why that can't be 1. If it's 2 here, if this were 4, this would be an odd digit because of the red courant. 4 and an odd digit never have a difference of 2. 4 can only have a difference of 2 with 2 and 6. So if this is 2, this can't be 4 here. It must be 1, and this is 3 to have a difference of 2. So if this is 2, this is 1 and 3. If this is 3, that would force this to be a 6, which would force this to be an even sum, but 6 in an even digit can never have a difference of 3, right? 6 would be a difference of 3 from 3 or 9, which don't work. So this cannot be 3. That means this can't be 6. What about 4? If you have 4, this would be 2 or 8, and this would be an odd digit, which doesn't work again. Because odd digit minus 2 or 8 is never going to have a difference of 4, right? The difference of 4 for 2 and 8 would be 6 for 2 or 4 for 8. And this has to be odd because of the red courant. So we know then this is 2, 1, and 3 here. So these have a difference of 2. These have a difference of 2. These have a difference of 2. Interesting. So do these, and then these. Remaining digits in this box are 4 through 9. The only digits that can be next to a black courant is 4, 6, and 8. Remaining of the digits in row 1 are 4 through 9. And similarly, the only digits which can be next to a black courant are 4, 6, and 8. If you have 4 here, this is 2 or 8. If you have 6 here, that's 3. 2, 8, 3, the same ones exactly. If this is 8, this has to be 4. So this is 2, 3, 4, or 8. In row 8, we have 6 digits next to a black courant. That means the remaining digits in the row have to be 5, 7, and 9. So this is 5, 7, 9 there. One of these is guaranteed to be a 2. Sorry, one of these is guaranteed to be a 1, which means 2 has to be one of these digits here. So one of these is a 1, which means we have a 2 in one of these digits to be in a 1 and 2 ratio with it. That means one of these must be a 1. This is 1, 2, 3, 4, 6, and 8. Obviously 1, 2, 3, 4, 6, and 8. These are 1, 2, 3, 4, 6, and 8. Interesting. And these must be 5 away from each other. So 4 can never be here. Which means 8 can never be these two. Right, 4 can only be 5 or more away from 9. So if these are 1 through 6, interesting. These always have a difference of 2. Therefore, there are going to be 2 odds or 2 even digits. Well, if there are 2 odd digits, you can't have 4 odd digits because there are only 3 remaining. So this must be 2 odds and 2 evens. Oh, interesting. So there must be 2 odds and 2 even digits here. This is an even sum. So that means the remaining digit must be odd. So it cannot go to both this and this because that's never going to be two apart from each other, right? Evens and evens can be two apart from each other. Odds and odds can be two apart from each other. So maybe, okay, so we're going to still have the lines, but the coloring, we're going to make it different. We're going to have the coloring actually be odds and evens. So this is even, this is odd, odd. This must be odd, and this must be even. Because the digits that match must match the odd and even amounts. They're only two away from each other. So they have to both be odd or they have to both be even if they're the same distance away from the cupcakes. Interesting. This is odd. These are guaranteed to be odd. This is even. Um, um, hmm. Hmm. One interesting thing here is, one interesting thing here is this is an odd even pair. Therefore, one of these is even. So that means we must have one odd sum. Well, we had to have one odd sum there anyways, right? Because 1, 2, 4, 8 is possible, and 3 and 6 is one of the other ones possible. So that doesn't really help too much. Um, um, hmm. This is odd. Uh, the two even digits here cannot. It's either 4 and 6 or 6 and 8. So this can never be 6 here. Which means 4 and 8, this can never be 3. We're guaranteed one of these is a 4, because it's either 8, 4, or 2, 4 in a 4 to 2 ratio. So 4 cannot be in the remaining digits in this box. 7 similarly cannot be here, right? This difference to be the 2 between these cells must be 5, 7 or 7, 9. 4 cannot be here. So since 4 can't be here, this cannot be 8. Interesting. So we know 8 has to be one of these 3 digits here, which means this cannot be 8 here. We know 4 is here, so this cannot be 4. So this has to be 1, 2, or it's 3, 6. 8 is here. So 3 cannot be here. If 3 were here, the problem is it would have to be next to an 8 on the next to the grape, which has a difference of 5. Oh, this can't be 3. So therefore this can't be 6. Other way around. This can't be 3 because this can't be 8 anymore. This can never be 4. If this was 4, the problem is this would have to be 2 because this can no longer be 8, but then 1 doesn't have a 1 to 2 ratio with any other digit then. So this cannot be 4 here. If this is 6, Okay. This is even. Interesting. So either F goes this way, which means P would have to go this way, and then these would all be even. But then this would have to all be even. So could that work? No. Well, maybe. I don't know. I don't think it works, actually. So red going that way, blue going this way, would mean these are both even. So we have 4 evens in, right? Because this has to be 2 away from this. This has to be 2 away from that. So those are both even to match that. Well, that would force this to be 1 and 2, which means this couldn't be 1 or 2. This would have to be then 4, 8 as a pair, which eliminates 4 and 8 here. So that's 2, which makes that 4. This is 6 and 3. I guess that's working okay. This can't be 4 or 8. So 6 would have to be here. No 6 here to correspond. You'd have 8. But 4 would have to be 2 away from that digit, which it's not going to be because it's 4 or 8. So we cannot go that way. So the path then has to go this way, this way, this way, which means it corresponds to this path here. This is even. So we have odd and odd. Whatever it's here, this is even. So this must be even, which means this can't be 1 or 3. It's 2 or 6. Which makes this not 2 or 6. It's 1 or 3. Which means this is odd. And this is odd. This only is odd if it's 3. So that's 3 and 6. Which eliminates 3 and 6 here. This is 1 and 2. Which means no 1 or 2 here, no 3 or 6. It's 4, 8 as a pair, which is even, which eliminates 4, 8 in the rest of the row. This can't be 4 or 8. It's 2, which has to be in 1 to 2 ratio with 4, which means this can't be 4 or 8. The 6 then has to be here to correspond to the 8 here. So this is 8 there. We have 6 here. No 6 here because of 6 in the box. 3 is here, 3 is here. This is 2 away from 5 or 9, which means it cannot be 5 or 9 here. It's 7. So this is not 7 here. We have a guaranteed 7 here, which means this cannot be 5 or 9. We have 6, 7 here. And the 7's next to 8 with 5 or 9 there. 7 eliminates 7 in the rest of row 8. This is 5, 9 as a pair, which eliminates 5, 9 in the rest of the box. So this is 4, 7, or 8 there. This is 1 and 2, which means this can't be 1 or 2 here. 2 can only be 5 or more away from 8. So this is 8, that's 4. These are both even, which means this odd has to be a 6. Sorry, this even here has to be a 6. So this is 6, which means these are all odd. Remaining digits of row or box 9 are 3, 5, and 9. Remaining digits of row 7 are 1, 3, 5, 6, or 9. No 3 here because of 3 in the box. 5 cannot be next to the grape because 5 can only be, this 2 eliminates 2 here, so this is a 3, 6 pair, which eliminates 3 and 6 in the rest of the column, so this can't be 6. Where is 6 in box 7? It can't be here because it must be 8 corresponding to the 6 here. Because this can't be 4 or 8 here, the even here has to be 6. So 6 has to be here. 6 can only be next to 1 on a whisper, on a grape. So this can't be 1 here. It's 5 or 9. So this is definitely odd. This is 6 here. This is 6 here. Where is 6 in row 3 then? Can't be here because we're guaranteed a 6 in this 3, 6 pair there. Can't be here because we're guaranteed a 6 in this red courant pair here, because one of these must be even. So this has to be 3, 5, 7, 9. So we're guaranteed a 6 in one of these two cells. Interesting. Two must be with a 4 to be 2 away from it. So this is 2 and 4, and this is 2 or 4. The 6, if it's with anything, has to be with 8, but we don't know. These are odd. So we have odd, odd. We don't know this. This is odd. This is odd. This is even. Where can the path not go? Obviously, this is blocked off. So this is no longer valid. Can't go here, which means that's blocked off. Um, um, hmm. Ah, if this tries to go even here, it has to be 8, which means it would have to go to a 6 here to be... Wait, 2 and 6 are not 2 apart from each other. Oh, that's bad. So that's not going to work. Ooh, that's really bad. Huh. Interesting. Okay. This logic still makes sense, right? These have to be 2 away from each other. So it's 6 and 8, or 4 and 6. And same with 7 and 5, or 7 and 9. So this is 4, which means this can't be 4 here. So this can't be 8 anymore here. Hmm. I think this logic still makes sense, right? So if we try to go this way, these are both even. So it could only go 2 even if it's even there. And if it's even there, the problem is this would have to be 4, 8, or 2, 4. And that's not going to work, right? Because 4 and 8 is not... Well, and the problem is this would not be 1, so this would be 1 and 2. And that you'd have that problem, right? So 1 has to be one of these 3 digits. Um, right. And then, so this is 1, 2. This has to be 4 and 8, which is not possible. So, yeah. F is definitely going that way. So this is blocked off now. P has to go that way. Oops. This way. So then that way and that way. Oops. Can this be even? No. One of these is This is problematic too. Right, because they are not going to have a difference of 2. That's the case. Hmm. Okay, let's restart. Red definitely has to go this way. Blue definitely has to go this way. Um, red definitely has to go this way. Blue's definitely that way. We have the same issue here. So again, what can this be? Say we have 1 here. That forces 2 to be here. This must be even. Even and 2 is never going to have a difference of 1, so that doesn't work. 2 here means this is odd. You could have 1 and 3 here, and that works. That's a difference of 2. You cannot have 4 here and an odd digit, because that's not going to have a difference of 2. So we have 2, 3, and 1. What about 3? So again, this digit can't be here. It must be here, and then it must be doubled somewhere else, because the difference between that and the digit that's opposite it must be the double. So that's why it's 1 through 4. If we have 3 here, this is 6. This is an even digit that's not going to have a difference. 6 would make that 9, but then that doesn't have... 9 and 3 are not different parities. So that doesn't work. And 4 means this is odd. This cannot have a difference of 4 with any other digit if this is 2 and 8. If this is 8, obviously that would have to be 4, which is not valid. If this is 2, this would be 6, but 6 and 4 are not different parities. So that doesn't work. So this has to be 2, 3, and 1. So that's guaranteed. Remaining digits in row 8 that are next to the black courant are 1, 2, 3, 4, 6, 8. No 1, 2, 3 here. 4 can be next to 2 or 8. 6 can be next to 3, and 8 can be next to 4. This is same, 4, 6, and 8, which can be 2, 3, or 4. 2, 3, 4, or 8 here. This is even. The rest of the digits in row 9 are 5, 7, 9, which are odd. These cannot be... We have 3 odds and 3 evens left in row 9. That means, and anything on the line must have a matching parity on the other side of the line. Which means on the line has to be 2 odds and 2 evens. Because we have 3 and 3 left. You can't have 4 odds or 4 evens left. So then this is even. And the difference between, again, has to be 6, 4 or 8, 6. So this cannot be 6 here, which means this can no longer be 3, therefore that's even, even. We have then 3 evens accounted for in row 9. So this cannot be even here, it's odd, and it must be 5, 7, or 9. Now, we tried to have this go this way, right? That would mean this cannot go this way because that's not a difference of 2. It would have to go this way, and these would then both be even. The problem, though, is if these are both even, this can't be 1, which means 1 is here, 1 and 2 are here. And we have that problem there. Right. 4 and 8 could only be next to 2 and 6 here, but because this is even, this has to be 1 and 2, because 1 has to be one of these digits. And because of that, that doesn't work. Right? Because 2 would have to be, 1 and 2 would be here. This would be 4 and 8 to be even, but then 4 and 8 is not a difference of 2 away from 4 and 8. Which means F has to go this way, which means it goes that way. P then must match it must go to the odd digit, and then here and here. But we have a kind of big problem here, right? 1, 2, 3, 4, 6, and 8. 4 cannot be either of these, which means 8 cannot be here, 8 cannot be here, because 8 would require 4 to be one of these spots. 1 is guaranteed to be here, so this cannot be 1 here, which means this can't be 6, so this can't be 3. We are guaranteed this is a 4. So we cannot go through this path. And the problem is, if this is odd and even, this has to be odd and even. Well, this is guaranteed to be even here. So this must be even here, which means this can't be 3. So we have 2, 6, or 8 here. Since this is not 3, this can't be 6. These have to be 2 apart from each other. These have to be 2 apart from each other. How does that even work? I don't even know. No 4 here. This can't be 7 because it's 7 and 5 as a difference, or 5 and 9, 7 and 9. 7, 5, 7, 9 as a difference in row 9. If we tried 1 and 2 here, that forces 3 and 6 here. 1 and 3 are 2 away from each other, but 6 and 2 are not, which is why that doesn't work. So no 1, 2. This can't be 2. If this were 3, and this is the problem, right? If this is 3 here, then this can't be odd, and then this must be even. So how is that going to work? Maybe it's the assumption that this can't be 6? Shoot. It has to be, though. This has to be 7. Which means the 7's here, so this can't be 5 or 9. Well, it was looking really good. Not so much anymore. Oh, no. Oh, that means it can't go that way. Okay, that's okay. Ah, I see it now. I see it now. I see it now. It has to go this way. It doesn't have to go this way. It could go here because this could be odd. But we tried going this way, and we've shown that that doesn't work. So then it cannot go this way. Here, it has to go this way, interestingly enough. Huh. Obviously this can't be 1. That means this can't be 6, no 3 here, no 4s here, which means this can't be 8. So that means it must go this way, and this must be odd. Since this is odd, this has to be even, which makes that even and even. So this cannot be 3 and 6, so that has to go that way. Aha. This is an odd digit. It has to be 3 or more away from, sorry, 2 away from 5, 7, or 9, which means this is 3. So this is 3, this is 6. That makes this a 5 here. So this is 1 and 2. That means 2 is one of these two. 4 has to be one of these, so this cannot be 4, which means, so this is going that way. This goes there. No 6 here. No 7 here. One of these is 7. This cannot be 5. No 5 here. It's 7, 9 as a pair. 4 and 8 is 2 away from 6. 2 and 8. 8 is 2 away from 6. So that's 8. This is 4. This is 2. That's 4 here. No 4 or 8 here. No 6 here. So we're guaranteed the 6 here. That means this can't be 4 here. We're guaranteed the 8 here. The 6 here. This can't be 2 and 4. It must be a 3, 6 pair. No 1, 2 here. This cannot be 3 and 6. So this is 8 and 4 here. So again, we have a 6 here. So this is actually all the same, interestingly enough. This is quite different. So we have 2, 1, 5 and 3 are 2 away from each other. 6 and 8 are 2 away from each other. 4 can only be 2 away from 2 or 6. Well, you can't reach a 2 anywhere here. So it must be reaching a 6 here. So this has to be 6 there. It must be the path going that way. So this is even. What just happened there? I don't know. That's blue. Okay, so this is blue. We have red, red. Okay. Remaining digits then are 5 and 8 in this box. Remaining digits in box 9 are 4, 5, 7, or 9. We're not sure which. And 5 cannot be here because of the 5, 8 pair. Remaining digits in row 7 are 1, 3, and something else. And this 3, 6 pair eliminates 3 here. So this is not 3, it's 1. Because 3 has to be here, and that must be 5 away from another digit, which cannot be 5 or 8. That makes this 3 and 9, which makes, that's why this is 1. Remaining digits in column 1 are 5, 7, 8, 9. So 3 and 9 are here. We cannot go this way. So where, okay, so we can't go this way. We can't go here for those paths. So we have there. This cannot go that way because it would have to cross or share a cell with P's path. So that means this must go this way. So we have that path. Could go that way or that way. We're not sure. 6 can't be here. 6 is one of these two. 4 cannot be any of these digits here. That means if 2 were to be here, it's not going to have a difference of 2 with any digit here. So 2 then has to be one of those 3, which means 4 is one of those 3. Okay. This cannot be 9. It's a 4, 7 pair, which eliminates 4 and 7 in the rest of the box. This 3, 9 pair eliminates 3 and 9 in the rest of the box, so this is 6 and 7. So that's fine. That's fine. Technically, P could go this way. These are all odd. That's interesting. This is even, odd, even, even. So the rest of column 9 still is all odd. So we have 3, 5, 7, 9 here because one of these must be even there. Hmm. Hmm. Okay. You cannot have them both going this way. And the reason is this is 3 and 6, and this is 6 and something else, which is odd. The 3 could be with 1 or 5 there, but the 6 cannot be 2 apart from the 6. So one of these has to go down this path. We don't know which. And then the other one has to go along this path. So one of them goes down this path. So we have 1, 2, 3, 4, 5, 6, 7. So this is 6 and 7. 1, 2, 3, 4, 5, 6, 7. Interesting. So either way, this cannot be 6. If it's 6, so it cannot be going this way and that way. Because again, the only even value here are 6s, and that's not 2 away from the other 6, right? So one of them has to go this path. Well, if this were 6, that's 1, 2, 3, 4, 5, 6 on the path. 1, 2, 3, 4, 5, 6 on the path. And you'd have 6 here and 6 here, which is not allowed, which is not 2 away from each other. And if you go that way, it's the same thing. So this cannot be a 6, which means 6 has to be here. This is 6. This must be 2 apart from it, and it cannot be 4 because the 4 has to correspond with the 2 in this box. So this is 6 and 8. So this is even, even. We have a 2, 4 here. The rest of these have to be odd. Interesting. So since this is odd, this correspondingly has to be the odd, which means the even has to correspondingly be here. And it has to be 2 away from 6, which is 4 or 8. Okay. So 8 cannot be here, which means this is odd. 8 is guaranteed to be one of these 3 digits. And it cannot be here because of 8 in the row, so this is odd. Interesting. We don't know which one of F or P goes through here, but it has to be 3 odds, which means this must be 3 odds or this must be 3 odds. Well, if that's the case, this is 3 odds or this is 3 odds. The rest of row 1 cannot be a pair of odd digits, which means these are both even. And we have 2 and 4 here. So that's 2 and 4. These are not 2 and 4. They are odd digits. So this must be 7 or 9 here. This has to be odd digits 2 away from each other, but could be many things. We have a 7, 9, 7, 9 pair in column. This had to be 7 or 9 because it's 5 or more away from 2. Therefore, the remaining digits in column 5 are 1, 3, and 5 if they're odd. The remaining digits then in the rest of column 5 could be 1, 3, 5. Oh. 1, 3, 5, 4, and 6. And 8. No 8 here because of 8 in the row. No 4 here. We are guaranteed in column 5, 4 has to be one of these two. We are guaranteed in column 5, 6 has to be one of these two. We don't know about 8, though. Hmm. Okay. Okay, this has to be 3, 5, 7, or 9. We are guaranteed a 2 in one of these 3 cells here. This is any of them. No 3 here. Interesting. Okay. Huh. Hmm. Um. Hmm. If this is 8, it would have to be next to a 6, and you'd have to have 6 go there. Um. So can it... Okay, so P can never go here. If it goes here, or it can never go here directly from the 6. Because 4 is not 2 away from 8. 7, it could be 7, 5. Okay, never mind. That could be the case. Never mind. Hmm. 7 and 9 here must be with 5, 7, or 9 here. Which means we're guaranteed one of these two is 7. One of these 3 cells, sorry, is 7. So we have guaranteed 7 there. Hmm. Remaining digits of column 4. We have 1, 5, 7, 8, 9. Remaining digits of column 6 are 2, 3, 5, 7, 9. Okay. No 8 here because of 8 in the row. So this must be odd. Okay. Hmm. Remaining digits of column 9 are 3, 5, 6, 7, 9. So this can never be 7 here. Can this ever be? It could be no. No. So if obviously this goes this way, this must match, and then this can't be 9 because it has to be 2 away from 1, 3, or 5. If we go this way, then this must match that. So this cannot be 6, which makes that 3. Then this would be 6, so this can't be 6, and then therefore this would have to be 6. So this can never be 9 there. That's interesting. We know one of these is odd, and one is even. Okay. That means we are guaranteed 3 evens and 1 odd in row 2, but that's not that helpful. Because we know one of the paths goes this way, right? So well, I guess we could check a look at these paths, maybe. Uh, um, hmm. Um, hmm. Um, so if this is 8, it can go 6 there. It can't, it could technically, no, it can't go 6 there. So if this is 8, this goes 6 that way. Obviously cannot go that way because then it would have to continue there, and this would be way too long compared to this path. So then it would have to go something weird or like this. It can't. I mean, it could go something like this and then go that way, maybe. But you could do. Can you go this and this? Would be another question. I think the answer to that might be no. Right? If you go here, here, that means it swaps parity. So I guess it could be 8 then. Oh, that's possible. 8 then 9 there. No, because then, yeah. So it'd have to be 5 and 8. Because if you try to go 8 and 9, the problem is 4 is not 2 away from 8. So it would have to be 5 and 8, and the problem is, again, 8 would not. So this can never enter this area. Okay. That doesn't tell us much, but okay. This cannot go this way, because if it goes this way, then these two would have to be two apart from each other, which is not possible. Hmm. Hmm. Remaining digits in box 6. We have 1, 2, 3, 5, 6, 7, 9. Obviously, no 6s here. No 3s here. Ah! What is the even digit here? They can't be 4, 6, or 8. There is an even digit, so it must be 2 here, which means 2 cannot be in the rest of this row. Huh. That doesn't really tell us too much, though. 6 has to be one of these 3. Eight has to be one of these 3. In column 2. Oh, obviously can't be here. Remaining digits in column in this grape. 1, 2, 3, 4, 6, 7, 8, 9. So no 6 or 8 here. No 6 here. Hmm. Okay, remaining digits of row 1. We have 1, 3, 5, 6, 7, 8, 9. No 3 or 6 here, no 3 or 6 here, no 3 or no 6 here. No 6 here or 3. These can't be 7. Can't be 8 here because of 8 in the column. This is guaranteed to be odd. Interesting. No 2, 4, 6, or 8 available. This... Could be even. Could be odd. Hmm. 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 Um, that means it can never get to here. Uh, hmm. That's interesting. Um, one interesting aspect is whichever way it goes, this is three odds and then an even, which means in the box we only have three more evens available. Oh, sorry, one more odd available, which means that has to be three evens. But you could do something like this, I guess. It's kind of weird. Hmm. How many more cells can you get to get to here? So if we try to go around here, that's at minimum one, two, three, 4, 5, 6, 7. 7 more cells, which is quite possible. Hmm. Um, hmm. So we know this cannot go that way. If it goes that way, 5 and 8 would have to be 2 apart from each other, so we can block that. So it goes either here, 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 or here. If it's 8, then it has to go here as 6. Um, oh, this 5 eliminates 5 here. That's interesting. So either way, this goes here. So if this one goes that way, that corresponds to the here. This can never be 5 or 1. This can't be if this is a 1, this would have to be 3 or this would have to be 3. But this can't be 3 because of a 3-6 pair in the box. This can't be 3 because of 3 in the column. So this can never be 1 here. And 5 doesn't work either because 5 has to be next to 3 or 7. Well, if it goes this way, that means this has to be a pair. So it's either 5, 7 here or 7, 9 here. Either way, that eliminates 7 from the rest of the row. You have the same problem with 3 not being in either spot. So this can't be 5. It has to be 3, I think. Right? Because again, 5 has to be next to 3 or 7. 3 can't be either of these because of the 3-6 pair in the box and the 3 in the column here. 7 can't be here because if this goes this way and this goes there, this is 7 and 5 or 7 and 9 as a pair, which eliminates 7 in the rest of the row. So this can't be 5, therefore this is 3 guaranteed, which eliminates 3 in the rest of the box. This has to be 2 away from each other, and you cannot have 1 be 2 away from 5, 7, or 9. So this can't be 1. Because of the 5, 7, 9 triplet, we cannot have 5, 7, or 9. This is 5 here, which must be 2 away from 7. This 5, 7 pair eliminates 5 and 7 in the rest of the box, so this is 9. This is 1. This is then 2 away. 9 cannot be 9 in the rest of the row. 7 has to be one of these two. 3 has to be next to 1 or 5. So 1 is 2 away from 3. So one of these two is a 3. So this cannot be 5 here. If it's 5 here, that would mean this is 6, which makes that 3, which makes that 6. Which means, yeah, it has to be a 3, 6 pair here. Because it has to be 2 away from 1. So this cannot be 1 or 3. That means it has to be 3 or 6 here, which means this 3, 6 pair eliminates 3 and 6 in the rest of the row. You could have 3 next to 1 or 5, and that works. This 3, 5, 7 eliminates 3, 5, 7 in the rest of the row. This can't be 3, it's 6, which makes that 3. This can no longer be 6 here. 3 eliminates 3 here, so that's 6. So this is it cannot go this path. Or, sorry, it has to go that path. Is that right? No. This must match 3 odd digits. So this must go then this way. So F has to go this way, and P then must go this way. So this is 9 and 7 here. This has to be a 1 as the remaining digit, which eliminates 1 and 7 in the rest of the row. So again, these are odd, and this is even. 5, 8 as a pair eliminates 5 and 8 in the rest of the box. So there's no 8, no 5 here. So it cannot go through this path. So this is no longer valid, because it would have to exit out the other way. Say, well, this could technically do something funky like that. So this is a boundary there. Remaining, okay, so this cannot be, there's no 3 or 7 here because of the 3, 5, 7 triplet in the row. So this is 9, which eliminates 9 in the rest of the column. So then this must be 5 here, which means this can't be 5 here. It's 8, 9 as a pair. That means 9 cannot appear in the rest of this box. The only high digit left then is a 7 here, which must, and this can't be 7, so 7 has to be here, which is next to 1 or 2. 7 eliminates 7 here, so it's 3. This can't be 3 or 5, it's 7. 7 eliminates 7 here, so it's 4 and 7, which means we cannot have a 7 remaining in box. Box 6. So 6 cannot go straight to 4, because if it were, then this would have to be 8, but the problem is 8 and 4 are not too apart from each other. Okay. Remaining digits of box 3 are 1, 2, and 4. Okay, and 1 cannot be here because of 1 in the row. This is therefore even. This is odd. 7 eliminates 7 here. Remaining digits of row. So this has to be an 8 here. There's no other place for it. So this is even. Remaining digits of box 1 are 2, 4, 5, 9. No 5 or 9 here, so this is 2 and 4, and therefore that's even. We don't know about these. So it goes either even, and it would have to be 8 to 6, or it's odd. Hmm. 7 eliminates 7 in the rest of the row. So no 7 there, which means 7 has to be one of these two digits there. 7 eliminates 7 here, so this is 6, which makes that 7. Therefore, this is even. This must be even to correspond. This is odd, and this is odd. Therefore, that makes this 8. This is 9. 8 eliminates 8 in the rest of the column, so it's 5 and 8, which eliminates 5 in the rest of the column. And no 9 here. So 3 and 1 are 2 apart, 8 and 6 are 2 apart, 7 and 9 are 2 apart, 5 and 3 are 2 apart, 8 and 6 are 2 apart, 4 and 6 are 2 apart. As are 6 and 8, 5 and 7, 4 and 2, 9 and 7, 3 and 1, 3 and 1, 6 with 4 or 8. Okay. Remaining digits in column 2. We have 2, 3, 4. Oh, this can't be 5 because of 5 in the column. 2, 3, 4, 6, and 9. No 4 here because of 4 in the row. Remaining digits of column 3 are 1, 2, 3, 4, 5, or 9. No 4 here because of 4 in the row. These can't be 2 because the 2 around the red courant must be the even digit. This is even. Odd here. So if this is even, that would guarantee this has to be even, and it has to be 6 there. So then that would be 6, 4. This would be 2. You'd have 8 there. So even. That means this would have to go that way. That would force this to be 5. Oh, and we'd have a contradiction. So if we have even here, 8 can only be 2 apart from 6, so it'd have to go 6 there. Then it would have to be even here, so it'd have to go there. The problem is, then this would all be even, so this would be 5. Oh, 9 eliminates 9 here, so this is 7, which makes this not 7, that's 9, which eliminates 9 in the rest of the column. Again, so if this went even here, we'd have to go even here. But then the problem is this would be 5, that would be 8. You'd have to go to 6 here, but you could only go to 6 here, and then they would cross paths. This path would already be completed, and this would not be even close. So cannot go this way. So this is boundary there. So it must go to an odd. And that digit must be 2 away from 5 or 9. Well, that's only 3 or 7 remaining. 3 and 7 can't be here. 3 and 7 can't be here. So that means it has to go here. So this is odd, and it's the path. So then this has to be 3, which makes this a 5. So we'd have 3 have to be there. This is 5 to be 2 away from it, which eliminates 5 in the rest of the column and row. That means this can no longer be 9. No 9 here. And 7, 8, and 9 have to be here. 3 eliminates 3 in the rest of the column and row. This is 2, 4, or 6, and is guaranteed to be even. If they go this way, it would have to be 2 odds and an even, which is quite possible, I guess. Hmm. So if this path goes this way, this is a 9. Because if it's 8, this path has to get to a 6, and it can't get to a 6. So this would be 9, which would force this going down there, which would be 7. You would need X. This would then go 8 there, but then you would need access to a 6, and you can't have access to a 6 because this is blocked by a wall, and this is blocked by the rounded edge of a wall. So you cannot go this path. So this is removed as a possibility, which means F must go this way. Which is either 2, 4, or 9. Cannot go diagonally here. That would go through a rounded portion. If this were 2, that wouldn't work because you don't have 4 available here. So this cannot be 2. So it's either 4 or 9 here. Which means 2 has to be one of these two. And 2 cannot be here. This is 1, 3, or 5 and is odd. If it's 4, it can get to 2 in either of these spaces. If it's 9, it has to go here as a 7. Okay. This has to either go to one of these two spots. Which means it's always getting to this spot. Right? If it goes this way, it has to connect to here, and that means it's connecting somewhere through here. If it's going here, obviously it connects directly to there also. Or it can, in some way. It cannot go this way, because if it goes this way, first of all, if it's even, that would be 8, and therefore there's no 6 available. If it's odd, it's 5, which does not have 3 or 7 available here. Oh, 3 does work. Never mind. Okay, never mind. It could get to any of these 3. Never mind. Okay, take that back. Huh. Uh... Hmm. What's the most we can go then here? Well, I mean, you could do some funky thing like going around there. So that's possible. Or going through here. That is possible also. Hmm. Can we go this way is kind of the question, right? How many? So, okay, let's try going that path. Obviously, okay, so this is going to be blocked off because you can't go through that anymore. So what happens if we try to go this path? Well, this can no longer get to 6. So therefore this can't be 8. This is then 5, that's 8. That makes that 4, which makes this 5, 6 as a pair. 5 means this is not 5, that's 7, that's 5. We need to access a 6, so it has to go this way. And then access one of these 6s. So then this would be 3, this would be 2, that would be 7. No 5 or 7 there. It's 1 or 9. So you'd have to access a 6. No 3 here. One or 9 would have to get to a 3 or 7. Well, okay, so then we have 3 corresponding to that. One of the 6s. We have one more digit and then 3 or 7. Well, that's not going to be possible. Well, unless we go this way, but then this has to connect there because there's no other way. And then this is too far. So this cannot go this way, right? 4, 5, and 6. This would be 4, 5, or 6, actually, if that's the case. This would be 4. You'd have 3, 5, 8, 3, 6. You need to get to 1 or 9, which means you have to get to 3 or 7. I guess you could go 6, blank, and 7. But then you have to close off that, right? It'd be 1, 2, and this would be 1, 2. And that would be too far. And then if you go 7 there, that doesn't work. You can't reach the 7 in 2 steps here because it's through a wall. You can't reach to the 3 because that's through a wall. You can't connect that way because that would close off that path. So no, you cannot go this path because it would make this path longer than this or shorter than this path. Guaranteed. So this has to go the other way. So that means red has to go through here. Okay, which is 3 or 9. Okay. If it's 2 odds, that means it cannot go this way. It could go that way. Can you be 3, 4 odds that way? Essentially. Maybe? That's gonna be tough. Huh. That means this is not possible. This cannot go this way. Because then it can't connect to this. So this is boundary here. Really, then you can't go through there because if you go any path, you can't go directly because that's not 2 away from these. If you go here, then you're blocked in. So then this is definitely boundary there. Right, you can't go this path. We have 3 and 9, which could be next to 1 and 1, 5, or 7, which is a wide variety. Can it go through this many, though? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Between this and this. I mean, you could do some funky thing like that, but it has to be 4 odds in a row. Um, Three has to be one of these 2 digits here. Shoot. So 3 is guaranteed to be one of those 2. Oh, that's interesting. So if we go through that, we need to be at 3 at 4 away. 2, 3, 1, 2, 3, 4. Or 1, 2, 3. Can't reach this 3. So it'd have to be. It cannot be 1, 2, 3, 4 because they have to be all odds, and one of these is guaranteed to be even. 1, 2, 3, 4 means that's way too small. So it'd have to do something like 1, 2, 3, 4. Or 3, 4. But this going this way, I guess it could be 6. So we have 8, 6. Odd, odd, odd. Or odd, odd. We don't know which one. So this would be both odds. These would have to be all odds. This would obviously be even. So this would not be 2, which means this is 2. So no 2 here. One of these would be 3 to correspond. The other one would have to be 2 away from 3 or 9, which is 1 and 7, but this can't be 7. So this would have to be a 1, 3 pair, which eliminates 1 and 3 here. That's 2. This is 9. This then has to go that way as a 9. And that doesn't work because this digit is not going to be 2 away from 9. So it cannot go this path. Okay. That was a long, convoluted way of figuring that out. So this is no longer valid. It has to go this way. Okay. Hmm. Okay, so we don't have to worry about this. So this is boundary. We don't have to worry about here. Can't go through there. So we have 3, and then we have to have 1, 2, 3, 4 more to get to these corresponding digits. So that's at least 1, 2, 3, 4, 5, 6, 7 on the path to get from here to here. 1, 2, 3, 4, 5, 6, 7 is possible. Or 1, 2, 3, 4, 5, 6, 7 is possible. I'm pretty sure it can't go this way. That's probably not going to work. If this is 9, then this has to go this way and is 7. Does that work? Let's try. 9 and 7 there. So that's 5. This is 7. This is 2. Which makes this 1, 3, 9. So this has to go that way if that's the case. This cannot be 9. It's 2, 4 as a pair. So it must go to an even. Which could be there. But that's going to block things. Well, okay. 1, 2, 3. Okay, so 1, 2, 3, 4, 5, 6, 7. Potentially. Either way, this even has to be a 2. Okay. Um... So let's make this 8. If this is 8, this is 5. This must be a 6 then. Which makes this 8, that 4. Okay. That means you have to go that path. You must go to an odd sum. So no 8 here. You have to have odd sum. It's 5 or 7. That's fine. Okay, that looks fine. Yeah, let's go back to this being 9. Okay, so if this is 9, that forces 7 here. 5, 7. Obviously no 7 here. This can't be 7, so this is 7 here. No 7 here. This is 2. No 2 here. So it'd have to go that way. We have 1, 2, 3, 4, 5. So we need 1, 2, 3, 4, 5, 6, 7. You can't go through here. If you go up and then down, well, you could go there and then that way. So you could do something like that. That is possible. And you could go that way, potentially. But if we're blocked with the 7, that does force certain things. This is not 9. It has, well, it doesn't have to go to 2 or 4. It could go to here. Interesting. 9 is here, which forces this to be 3, which forces this to be 9. Okay, that's interesting. There's no more 3s here. These are all even. 2, 4, 6 eliminates 2, 4, and 6 in the rest of the column. Or box. So this is all 1, 3, 5, which is all odd. Interesting. This is 9. We need access to another 7. Which is not going to work. Because we have 2 away, we need access to a 7. There's no way we can get 7 except here, and then that would close this path. This path would not be finished yet. So it cannot be 9, which means it has to go to a 2. So this must be 4. This is 2, that's 9, which makes this 3, that's 9. No 3 here. No 4 here. This is 2, 3, 6 as a triplet. This is then to an even. This is an odd. So we have to get to 2. It could go to the 7 here, so that is possible. It could go 2 here. We don't know which one. Okay, this is 3. That means 2 away from the 6 must be a 1 or 5. We could do something like that. 6, 5, we could do something like that. This is kind of blocked. Does that help us? Not particularly. You still could go 2 in either of these directions. You could go 2, 7 there, potentially. So we need access to a 5 or a 1. Yeah, this is a boundary here. It's quite wide open still. This is actually quite tough in execution. The idea isn't too bad. The execution is quite difficult, I would say. We have a wide variety of things it can be. Oh, can it ever get to 2 or 6? I think the answer to that, well, it could do that. And then go around here. That's interesting. Or it could do that. This is a wide variety of paths. I mean, considering how much information we have, this is actually quite difficult. To get to 2 or 6, you can get 4. You cannot get 8. So you could get 4 this way. Oh, no, you can't go that way. So it'd have to be 4 that way, then, if that's the case. Let's try it. So, what happens if we go this way? If we go this path, blue cannot go here then here, because that's it goes through a rounded part. It has to get to a 4 or an 8. So then it would have to go here then here. So then this would be 2 to be 2 away from 4. And then 4 to be 2 away from 2 or 6, which means this can't be 2. So it's 1, this can't be 1 or 4, it's 2. That eliminates 2 from these cells. This can't be 1, this is 3, 9 as a pair. Which means this is odd, so this must be even, so that's 2, which eliminates 2 here. Okay, then this could potentially go through this path. That's actually possible. 2 eliminates 2 here, so that's 6, which makes this 3. Therefore, that's 2. No 3 here, that's 9 and 3 there. 9 eliminates 9 here, so it's 7. No 7 here. No 7 or 9 here. We have a wall. We don't know what that is. Okay. Obviously cannot go to the 2. Could go to any of these 3. You could go 4 to 7. You could go way the heck around. Actually, is that going to work? So say they try to go 9 here. That's 7 here. This would have to be 1. This would have to then be 3, which is not possible. So it cannot go that way. Cannot go to the 2, because this is not 2 away from 2. These are odd. So then it has to go to one of these 2. This has to get to a 5 or 7. 2 is not going to be... Cannot go to 9. That's not 2 away from 5 or 8. So then it has to go this direction if that's the case. So then this would be 6. This would have to be 8. You'd have to get to a 5 here. So this is 6, 5. That's 3. Cannot go here. Could go to even. So that's still valid. Jeez. 6 eliminates 6 here. So this is odd. This 1, 5 pair. This 1, 5 pair eliminates 1 and 5 in the rest of the row. So this is 4. Which means this is even. So it must get to a 2 here. Okay. So far this is okay. Cannot get to 3. Cannot get to 2 because this can't get to... could be 4. Never mind, it could do that. Wow, this is quite convoluted. This might be the path. Because so far it's working. Okay, 5 eliminates 5 here. So this is 1, this is 5, that's 1. No 1 or 5 here, it's 6. No 1 or 6 here, it's 5. This can't be 1 or 4, it's 5. We have a contradiction. How did that happen? Oh, because I had that as 5. Okay. Right. So that's a long, convoluted way of showing that that can't work. So this cannot go this way. Oh my god. This is quite painful, actually, to do this. Anyways. Going that way means this has to go to a 7. So it's 7 there. This is 9. That's 7. Didn't we disprove this? I don't remember. I think we disproved that, which is quite different. This is 7, which makes this 5, 7, 2. No 7 here. No 7 here, so this is 7 there. 2 eliminates 2 here. This cannot go that way because this is not going. This is just connecting that way. So it has to go that way because it can't go to the 2. Can't go to the 6 because then it's stuck going the 2 or 7 here, which is not 2 away from 3. So then this must be 5. This has to be 8, 4. No 4 or 8 here, no 5 here. 2 away from 5 is only 3 or 7. Cannot reach here, so it must go to here, and that's 3. So that's would be there. No 3 here. Has to get to 2 away from 3, which is 1 or 5. But if it goes this way, this is gonna be stuck here. So it'd be 1, 2, 3, 4. So we have 3, 1, 2, 3, 4, and that doesn't reach the 9. So cannot go this way. It has to go this way, right? Because it goes, again, this is the smallest path. I can't even do that. 1, 2, 3, 4. Yeah. So that would be the smallest path. So it has to go to one of these two. 1 or 5. Then the problem with that, so 3 eliminates 3 here. Okay, so this is 3, that's 6. This is 2, that's 3. No 6 here, this is 5, that's 6. 5 eliminates 5 here. And here, this can't be 6, this is 1. So that's 1, 9, that's 4. Okay. Which means no 4 there. No 9s here. No 1s here. This is 2, 9, which forces this to be 1. No 1 there. It's 2, 4. So no 2, no 1 there. 6 eliminates 6 here, so it's 5, 1, 5, 6, 8, 1. So far, this is actually looking okay. We have to figure out the path then. So 4... We could go, so it could be 1, 2. Yeah, that's not going to work. It can't be 1, then 2. But it can't be 5, then 6, because it can never reach back to connect to this path there. So then I think that's the contradiction then. Right? We have to get something that's 2 away from 4. 2 and 6 both fit, but the problem is this is too quick. So we go 5, 2. Then it has to be 2 again, which none of these are consecutive with, so it can't work there, or it completes too quickly. If we go here, it can never connect back to here, because it's blocked by its own path. So that's why you cannot go to 9. Okay. This is so convoluted. So that means you have to go this path. Okay. Can't go back here. So then we know this is not a path. So this is a path. It must get to 2. So it cannot go straight 2 and then here. Could go 2 here. Then to 2. That is possible. Could go 2 and then 2. Ugh. Don't know. This is really kind of complex. Oh. Execution on this is very hard difficulty. I don't think I would classify this as hard. This is a lot of... Oh, this is 3, so this has to be even. Duh. Okay, maybe that's the problem. So then this is 8, this is 5. Okay, that makes things much easier. Never mind. This is odd, so this must be even. I could have done that in the very beginning. Oh man, that was a lot of stuff that I went through to get through that portion. So then this is okay, this has to go this way. Well, there you go. Yeah, I forgot the parity thing there. So that's 6, that's even. This is 8, this is 4. Oh, that makes things so much easier. This can't be 4. This is odd. This can't be 1 or 5. It's 4, so that's even. So 6 has to get to 5 or 7 here. Okay. So this, we don't have to worry about the boundary anymore. We have 6, then we need to get to 5. So one of these is 5. Which means this can't be 5. That's 7, which makes that 5. So no 5 here. No 7 here. This is 2 or 5 to be 2 away from 3. These are all odd. This is even. 6 eliminates 6 here, so that's 3, which means this can't be 3 here. These are 2 evens. This is odd as a 3. There's no 3 available here. Where's the 3 in box 6? It has to be here. So that's 3 is odd. This 6 eliminates 6 here, so it's 1 or 5. We need access to a 6 or 2. So it's going to be 5 and 2, or 5 and 2. Or 5 and 2, or 5 and 2. This is odd. This is even. That means this can't be 8 here. Where is the 8 in column 1? It must be here. So this is 8. That's even. These are odd. This is even. Still kind of convoluted, but I forgot about that. Everything else seems fine. Hmm. 6 and 8, that's 2 apart. 3 and 5, that's 2 apart. Can't be 1 here. Then it must access a 2. 3 is accessing a 2 in one of these spots. Then it must access 3 or 7. So it technically could go this way. Okay. This is odd. Even. Odd. Technically still could go around. Very unlikely to. Oh, can't go through diagonally here. It has to go that way. So then this must go that way. That is a 5. To be 2 away from 3. That makes this 2. That's 2 there. So this is odd. These are both even. This cannot be 2 anymore, so it cannot go this path. It has to go this way. So then that goes that way. This has to go this way. So it cannot go through this path. 2 has to get through here. So then this is to 3. We have to 2 to 3. 3 is 2 away from both 1 and 5. 2 eliminates 2 here, so that's 1. This is 9. This cannot be 1 here. It's 2, 4 as a pair. This is odd. This is odd. 9 eliminates 9 here, so this is 1. That makes this 5 and 1. No 1 or 5 here. It's 2 or 6, and that's even. And this 2, 4 pair eliminates 2 here, so that's 6, which makes this 2, which makes that 6. No 1 here. 7, 9 as a pair. This cannot be 1, 2, or 6, so this is 5. That's 1. Three, 2 to 3, 4 to 2 here. You could access. You cannot get to 1. So this can only go to 5 or 1 here. If you go to 1, it has to reach a 3, which is not possible here. So this must go to 5, which means it's 3 or 7. Again, 3 is not possible here, but you can reach 7 going that way. So that's 7, which makes this 7, that's 9. And it cannot connect to a 3, so then it has to connect directly back to the 2. So then this connects there, and this connects here. And these are both odd. 4 eliminates 4 here, so that's 2, which makes that 4. And that 4, this is 7 and 9. That was still, I think it was, execution-wise, it was very hard. Experiment completed successfully. Date, January 28th, 1975. Cells visited, 41. Black currants eaten, 4. Red currants eaten, 3. Grapes eaten, 0. The differences in character are perhaps even more interesting than the physical ones. When F was young, in Phase 1, her brilliance was evident from the start. But she was also excitable, ever curious and always eager to please us. She mellowed somewhat during Phase 2, but seems reinvigorated by the new arrival. P, on the other hand, really takes things in her stride, moving through each maze with a calm confidence that feels deliberate and unhurried. Yeah, I missed this part here. So that was bad on my part. Though, yeah, it's still, the execution of this would have been quite difficult, I still think. We had to go through a lot of scenarios to go from here. Right. I think I would classify this as very hard. Logic-wise, it's not that hard at all. But the execution is always kind of where you're running in, like it's the hard part here. And there's a lot of very hard execution in this puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.